Hello and welcome to N28, the beginning of limiting reagent stoichiometry. Similar to the Stoich we have been doing, but we're just adding a few more steps. So, limiting reagent stoichiometry, a type of Stoich problem where you run out of one chemical too soon and have extra of the other chemical left over. So, limiting reagent, just like a limiting resource, something's going to run out first. And our goal is to determine which of those reactants runs out first, which is going to control how much product you produce. So once you determine both limiting and excess, in order to solve for how much product is produced, you must compare it to the limiting reagent. And we'll see some examples of that as we go through it. So how do I know if it's a regular Stoich problem, like we have been doing, or a limiting reagent stoichiometry problem? We have to look for some key things about the problem that will identify being regular Stoich or a limiting reagent stoichiometry problem. So first little hint, how many starting values? When you only have one starting value given, it's a regular Stoich problem. If you have two starting values given, it has to be a limiting Stoich problem. It's kind of clear as day based on those two things. So regular or limiting. Let's look at the one on the left. If you react 25 grams of hydrogen gas with oxygen gas, how many grams of water can you make? And then on the, we only given, we are only given one starting value on the left-hand problem. On the right-hand problem, if you react 25 grams of hydrogen gas with 30 grams of oxygen gas, how many grams of water can you make? So, how many starting values? We have two. So we can realize that the question on the left is going to be a regular stoichiometry problem, and the question on the right is going to require limiting reagent. Any questions so far? Okay. All right, so some key terms. Limiting reagent, or LR, the chemical you're going to run out of too soon, or again, it's a limiting resource to the problem. Excess reagent, XS, the chemical that you have extra left over once the reaction ends when you have ran out of the limiting reagent. So we tend to have three types of problems when we are doing limiting reagent stoichiometry. The first type of problem is just determining what is the limiting reagent. Simple enough. The second one is determining how much we made of product. That's like what you've been doing with regular stoichiometry, determining the amount of product produced. And then now we also have finding out how much excess is also left over. So we're going to go through all three of these to try to see what's going on and how they work and ways to solve them. But in the end, it still comes down to mole ratios. The mole ratio, as we said before, is the key to stoichiometry. Dun, dun, dun. Yay, the key to stoichiometry. Then you add some dimensional analysis, you focus on some units, you're labeling stuff. All that stuff is required. I need to see in your work the setup, the units, things crossing out, things canceling out, and then solving for the answer. So we are going to use mole ratios and dimensional analysis to compare the following. We need to know what we need versus what we have. The haves are the givens in the problem. The need is what you have to solve for. And then you compare the need to the have, and that will help you to figure out, is that reagent limiting or excess? All right, so let's get into the steps involved in doing this. Always got to get to moles. Stoichiometry, in any sense of the way, only works with moles, so we need to get to moles. So grams to moles is what we've been doing so far. Then we need to compare have versus need. Identify which thing is limiting. And then if the question is asking for it, we do stoichiometry with the limiting reagent in order to solve for how much product is formed. Also, if the question does ask for find or determine how much excess is left. So the first three are a given. 4 and 5 depend on if they are actually asked for it. Questions so far? Okay, so let's take this problem. If you reacted 150 grams of potassium with 225 grams of bromine, how many grams of potassium bromide can be made, and how much excess reagent is left? So this problem, this problem is going to help us look at all three of those questions that we want to solve. So we want to figure out which one is limiting, because again, I have two amounts, both potassium and bromine have a value. I want to determine how much of potassium bromide is made when the reaction is done, and I also want to figure out how much excess is going to be left over. So let's start off with number one and go through that process. So if you reacted 150 grams of potassium with our 225 grams of bromine, we got to figure out which one is going to be limiting. So we have to start and figure out grams to moles, because stoichiometry only works with grams to moles. So I'll take my potassium, divide by the molar mass, and I get my moles of potassium. I'll take my bromine, divide by the molar mass, and I'll get my moles of bromine. Any questions on this step? Okay. All right, notice here on the right-hand side, now we have to look at the have versus the need. Well, let's look at this together. We have this many moles of potassium and this many moles of bromine. That's what was just determined on the previous slide. Well, how much do I need of potassium? Now, I can solve this either way. I can solve for the need of potassium, or I can solve the need of bromine. Doesn't really matter. You pick one and go for it. You're going to get the answer you need no matter what. So let's take potassium, and we're going to multiply by the mole ratio of bromine to potassium. Misspoke there really quickly. We're going to determine the amount of bromine needed to react with all of the potassium that I have. So by multiplying by the mole ratio of bromine to potassium, as you see, this is going to tell me how much bromine is needed to use up all of the potassium. So now I can compare how much bromine I have, 1.408, versus how much bromine I need, 1.918. Therefore, we can see that I have not enough. Therefore, bromine has to be the limiting thing. The nice thing about this, as I said before, it doesn't matter which starting value you try first. Cuts down the length of the problem, the work a lot. You could have just started with 1.408 bromine instead, and solved for how much potassium that you need, and you compare them. If you have more than you need, it's in excess. If you have less than you need, it is going to be limiting. Questions so far? Alrighty then. So we figured out we do not have enough bromine. That makes it the limiting reagent. You're going to run out of this first. Therefore, potassium is going to be my excess reagent, and you will have some extra left over when the reaction is done. So, again, quick reiteration. Pick one of your reactants. Solve for how much of the other one you need, and then compare the have to the need. Now, please note, showing this work is what I'm looking for, doing the stoichiometry in order to determine which one is limiting is what is required. Now, on a side note, there is a shortcut method to identifying the limiting reagent. I tell you this shortcut method as a way for you to double check your work. This does not count as showing your work when solving for what is limiting. This is just a thing you can do off to the side or in your calculator to make sure the reactant that you chose as limiting is limiting, because this works every single time. So, what am I going to do? The shortcut is pretty simple. You're still going to convert to moles, just like we have. But what we're going to do now is we're going to divide each of those mole numbers by its own coefficient. So potassium is going to get divided by 2. Bromine is going to get divided by 1, the coefficients. Easy enough. If I divide potassium by 2, I get 1.918. If I divide bromine by 1, I get 1.408. The smallest one wins. Since 1.408 is less than 1.918, I know that bromine has to be limiting and potassium has to be in excess. It is a very quick, short determination, but it's just for you to double check what's going on. The shortcut is there to help you verify what is limiting. Again, you must show your work, like the previous example, to prove what is actually limiting. And apparently I can't spell limiting at the very bottom there either. So, yay for me. Any questions on this shortcut? Alrighty then. This is going to be the end of part 1, and we'll pick up part 2 the next class period. Thank you very much. Bye-bye.